Alright, in this video we will practice simplifying expressions with radicals, with different roots, and fractional exponents, also known as rational exponents. Now, if you have access to a TI-30 XS multi-view, such as this one, you should learn how to use it, and I'm going to help you. So, I'm going to try typing in this entire expression to see what happens. So let's see, I've got parentheses and then the fourth root. So open parentheses. To do the fourth root, you type the number 4 first, and then you do second and the caret here, and it turns that into a fourth root of 256, close parentheses, fifth power. So 256, and now I can close the parentheses and do that to the fifth power. Kabam! 1024. Now, if you need to show some work, you can do it in stages. You can do the fourth root of 256 separately, like this. Again, you type the 4 first, second caret, 256. So that gives you 4. Alright, so that's this inside part. Just became a 4. Now you've got 4 to the fifth power, so you can now do 4 to the fifth power, and there's your 1024. Alright, either way. Number 2. Let's see if we can put this in our calculator. 32 to the 4/5 power. So there's 32 to the fraction 4/5. Oh, look at that. That's 16. Alright, you also could understand that when you have a fractional power, like if you have n to the p over r, then the numerator is always the power and the denominator is always the root. So it's always in the form power over root. So this is fourth power, fifth root. So fifth root, you say. So fifth root of 32. And then what, 4 is the power? So there you go, fourth power. So fifth root of 32, again, you type the 5 and then do your second caret, becomes the fifth root of 32 is 2. And then you've got 2 to the fourth power is 16. Okay, either way. Now, number 3. Something tells me that putting this in my calculator won't quite get the job done. Let's see what happens if I try. 100 to the negative 5 over 2 power. So let's see. 100 to the negative 5 over 2 power. See, I just get this decimal, and I don't want a decimal. Well, let's see, can I fix it by toggling it? No, sometimes that'll change it. So having a decimal like this is not what we want. We want no decimal, so we need another way. We know that n to the negative 1 power is 1 over n, or n to the negative 2 power is 1 over n squared, or n to the negative 3 power is 1 over n to the third power. You get it. So that means n to the negative 5 over 2 power is 1 over n to the 5 over 2 power. You just drop it down to the denominator. Alright, so it's just going to be 1 over something. So what's 100 to the 5 over 2 power? Maybe my calculator can do this part. 100 to the 5 over 2 power. Alright, so that is 100,000. That means this is 1 over 100,000. 1/100,000th. So that is the answer that you want, not the decimal. What about this? Can my calculator handle 125 to the 2/3 power? Let's see, 125 to the 2/3 power. 25. Okay, that's just fine. I mean, I could break it down in stages. Remember, this is power over root. So if I wanted to do the cube root of 125 and then square that, guess what? The cube root of 125 is 5, and then 5 squared is 25. Okay, what else we have? Simplifying this stuff. Now, again, something tells me that if I put this in my calculator, I'm just going to get a decimal. But let's see. If I want the cube root, so I do 3, and then I do second caret. Now I've got the cube root. I've got some fraction in here, 16 over 1,000. Okay, I just get this ugly decimal. So that's not what I want. So I'm going to have to be more careful than that. So one thing, if you have the root of a fraction, that's the same thing as the root of the numerator over the root of the denominator separately. Now, the cube root of 1,000. Cube root of 1,000. So cube root of 1,000 is 10. Alright, by the way, we're going to be using this table a lot. Alright, this is something that you're allowed to use for this particular test. So the cube root of 1,000 is 10. That's how I could use the table to do the same thing. Okay, so anyway, so the denominator is going to be 10. Now the cube root of 16 is not on the list, but what is on the list is 8. So what I need to do is, I could break this down a little bit. The cube root of 16, I could simplify this a little bit, alright? So cube root, because 8 is on the list, and 16 is 8 times 2, what I could do is I could rewrite 16 as 8 times 2. Okay? Now, 8 is a perfect cube, so I can take the cube root of 8 and put that in the front. So what's the cube root of 8? Well, the cube root of 8 is 2. So I'm going to have 2 outside the radical. And then that's going to leave the cube root of 2. Alright, that blue 2 right there, cube root of 2 is left behind, and the 10. So that is the answer for number 5. Let's see, how about number 6? Will the calculator handle this? Let us find out. So let's see, we have negative 2 squared and negative 2 to the negative 5 power. So I've got negative 2 squared and negative 2 to the negative 5 power and negative 2 to the 7th power. Oh, look at that. The answer is 16. Now, here's a more hardcore way of looking at it. You know that when you do, for example, n to the 3rd power times n to the 5th power, that's n to the 8th power because you add the powers together. You know that if this had been a negative 5, then I'm still adding these powers, but 3 plus negative 5 is negative 2. Alright, and if that were the answer, you'd do like 1 over n squared. But anyway, the point is, you can add these up and get negative 2. So that's the same thing we could do here, just add the powers, alright, because these bases are all the same. So this would be the same thing as negative 2 to the, let's see, 2 plus negative 5 is negative 3. Negative 3 plus 7 is 4. So then I've got negative 2 to the 4th power. So that is going to be 16. Notice it will be positive 16 because if you raise a negative number to an even power, the negatives all cancel out and you get a positive. So that's a more hardcore way of doing number 6. Number 7. Let's see what happens if we try to type this thing into the calculator. Alright, so we have open parentheses 27 to the 4/3 power, so to the 4/3 power. Okay, and then that's going to be to the negative 1, negative 1/2 power. Okay, that gives me 1/9. So, kabam, that's the answer to this problem. Now, I know what you're thinking. That was too easy. Is there a more hardcore way of doing this problem if I wasn't just going to use my calculator like that? Well, yes. Hopefully you know that, for example, if you had n to the 3rd power to the 5th power, this would be n to the 15th power. All right? If you raise a power to a power, you do multiply. So with that in mind, that's what we have here, a power raised to a power. So I could multiply, multiply these two together. So if I do 4/3 times negative 1/2, first of all, positive times negative is a negative. 4 times 1 is 4. 3 times 2 is 6. This reduces, all right, both of these are divisible by 2, so that'll give me negative 2/3. So that's what I get if I multiply these together. So this is really 27 to the negative 2/3 power. Now you know that a negative power drops you down to the denominator. So this would be the same thing as 1 over 27 to the 2/3 power. Now, when you have a fractional power, you know that you have power over root. So I've got 1 over 27. Now 3 is the root, so I'm talking about the cube root of 27, and then 2 is the power, so that would be squared. Okay, so I've got 1 over. The cube root of 27 is 3. So that means I've got 3 inside of the parentheses squared. So that's where we get 1 over 9. Alright, so this will be the last problem on this video. Number 8, we've got some variables to deal with, but basically I would treat this as 3 separate little problems. We've got 15 over 5 to deal with. We've got x to the 4th power over x squared. And we've got y squared over y to the 3rd power. So far all I've done is recopied it with the different parts spread out. So looking at this part right here, 15 divided by 5 is 3. So if I sort of still keep this in fraction form, then, you know, technically I'm doing this. Both of these are divisible by 5. Right? So 5 divided by 5 is 1. 15 divided by 5 is 3. So the 3 is in the top, and I don't really need the 1 down here. Now with these right here, x to the 4th power over x squared. Think about that off to the side. X to the 4th power is like x, 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 x. X squared is x, x. These two x's cancel out these two x's. So that leaves me with x squared in the numerator. So that's why I'm going to have x squared in the numerator. Similarly over here, y squared over y to the 3rd power. That's like y squared over y to the 3rd power. So these two y's will cancel out 2 of these y's. That'll leave 1 y in the denominator. So I'm going to have 1 y in the denominator. So that's it. This is going to be my answer to number 8.